9,000. Yeah, there you go.
Okay, nice.
Sutayta Mahamali was born in 930 in Baghdad, the center of mathematical advancement during 10th century.
Because of the House of Wisdom, because of translation movement.
Her father was a famous judge, Abdullah al-Hussein.
Al-Mahamali's expertise in mathematics known to people working in House of Wisdom. One of the areas she was good in inheritance. The type of mathematics Al-Khwarizmi pioneer. Al-Khwarizmi was of course, father of mathematics. So today we're going to be talking about one of the inheritance math problem, and that will probably allow you to appreciate the algebra invented by Al-Khwarizmi and advanced by people like Sutayta al-Mahamali. We're going to solve inheritance mathematics problem. So a father left some money for his children. Father left some money. He wished to distribute the money equally to all his children, right? He called the first child and he said, first child, and he said, would you be able to, okay, first child, and he said, you're going to get 1,000 plus 1/10. Okay, 1/10 of the rest, right?
Okay.
1/10 of the rest. And then second child, and he said you're gonna get 2,000 if you like to put a dollar sign, and 1/10 of the rest, and so on. Now the question is, how many children does he have and how much money he left? We're gonna use the algebra to solve this problem.
Oh wow, long time since I've used algebra, man. So I would need an x here, I guess, for the amount of children.
That's a good start, always.
We're going to start with an equal because I'm going to need a formula.
Right, right.
The problem is that if I was solving just for x, I would have a number value here. But you're telling me I have a second variable here, which we're going to call y.
We're going to have two variables.
Y would be the amount of children, x would be whatever he's going to leave over. And from there, you got to take over.
So I'm going to give you some hint.
Okay.
So let's say a diagram, and let's say the first child going to get 1,000. Okay, and then 1/10, right? And we're going to call this, if you want to use this pink, you can call this variable that you use x.
Right.
Let's call this x.
Okay.
And then the second child, this is the first child, and the second child, 2,000. I'm sure you are not crazy for the dollar sign, right?
Right, yeah.
Okay. And then 1/10 of the remaining, right? So if you want to use the pink to call it the y, you can do that.
Okay.
And then we can say x is equal to y, right? So let's say the first child, child is equal to second child.
Plus 1,000.
No, because all child has to get the equal amount of money, right?
Oh, that part I missed before. Okay, got
Right.
it.
All child has to get, every child has to
Every
get
child's
equal,
gonna get the same. Okay.
same amount of money. So let's see we can resolve this problem. So the first child, 1,000 plus x over 10 is equal to 2,000 plus x can be more beautiful, y over 10. Now let's see what is y. Can you write what is y now from this diagram?
From this diagram. So that would be...
If we know y, we know we can break this puzzle. Then we're going to have only one variable.
Right. So I would minus 1,000 here.
No, what would be the y?
Oh, what would be the y?
Right.
Wouldn't I have to solve the formula to get the y?
No, from this diagram we would be able to write y.
1/10.
So y is equal to x. No, y would be able to. We're gonna write y in terms of x because we want one variable.
So it would be
x minus what? X minus what is y?
2,000.
Okay, I put 2,000 minus what?
1/10.
1/10. Yeah, there you go. 1/10 is not 1/10. Minus x over 10, right? Right? Okay, now this is 1 over 10y. Now we can replace everything by this, and then we're going to have only one variable.
Christ, I'd have to follow it again, but yeah.
Right? So we have x minus 2000 minus x over 10. If we erase that, and then we can replace this by that.
Replace that by that.
And then we have only one variable.
What is this, like a new way you're teaching algebra kind of thing?
No,
That's not how I remember doing the equations. Like this, you got me with this little graph
that's right.
here.
That's right. But we can do it quickly. Let's do it, and then it's gonna be. If you see the answer, then you appreciate it more.
Okay.
Okay. Then we are not. You're gonna feel like you did not waste your time. 2000 minus x over 10, right? This 1000 and this 2000 can be written as negative 1000, right? And then plus x over 10 is equal to this, distribute it, so x over 10 minus 2000 divided by 10, 200, minus x over 100, right?
Okay.
This guy cancel, right?
Okay.
So if you send it to the other side, then this become what? This become x over 100, and if you send it to the other side, this become, there you go. Divide both side by, multiply both side by 100. 80,000. X is 80,000. Did he leave 80,000 or a little bit more?
80,000 or 800?
No,
A
80,000.
little bit more because of the one.
81,000. Okay, so he left $81,000. You're so close. How many children he has?
What do we say children is the y, so that's gonna be.
You can see the first. You can solve the first one. X over 10.
All right, hold up.
So close. We know the x is 80,000.
This is 8,000. Okay.
So
80 divided by 10. That's 8,000, and that's 1,000. So that's 9.
9 children he has. Yeah, he has 9 children. Yes.
Nice.
So yeah, 9 divided by 1. So every children gets
9,000.
9,000. Yeah, there you go.
Okay, nice.